Hello friends, welcome to the channel of Digital to Real. Today, what I am going to do? I am going to write the Verilog code of sequence detector. Now, what we need to detect? We need to detect a pattern and the pattern is 1011. And where I have to detect? I have to detect the pattern 1011 in the input stream of data. So the sequence detector is based on Mealy FSM. The FSM which is used in the sequence detector is based on Mealy FSM. What is Mealy FSM? The FSM where the output of the state machine depend upon the present state and the input applied to particular state. Also, this is overlapping sequence detector. Here is the state diagram for the Mealy FSM. So, what I have to detect? I have to detect the pattern 1011. How many bits are there? 1, 2, 3, 4. So, I am going to have 4 states. S0, S1, S2 and S3. Now, S0 state is the idle state. If it get one input, then the state transition will happen from S0 to S1. If it doesn't get the one input, it would remain in this S0 state only. When it remains in S0 state, output is 0. And when it moves from S0 to S1 state, output is still 0 only. Output bit will be 1 when 1011 pattern would be detected. Okay. So S0 to S1 transition happens when it gets the 1 input. Now it has got 1 and it has reached S1 stage. Now in S1 stage, if I apply 0, then I will make transition to S2 stage. In this stage also output is 0. But if I get in S1 state 1 only, means previously it was 1, another 1. So I will remain in S1 state only. Now after reaching the S2 state, if I get 1, then I move to the S3 state. Then what is the pattern it is forming? 101. Okay. When from S2 state to S3 state, when the transition happen, it happens for input 1 but output is 0 because pattern is 101. It is still not 1011. Okay. But in S2 stage, after 10, again if 0 comes, so 100, so the pattern breaks. That means it has to go back to the S0, that is the idle state, because the pattern has broken. Now in S3 stage, if the input applied is 1, then what the pattern form? 1011. Oh, our pattern is detected. So output is also 1. Okay. But you know 1011. So this last one can be the initial input of the second pattern of 1011. So it will go from S3 stage back to the S1 stage. Because if in the S1 stage it gets 0, then 1011 can again the possibility of patterns. Okay, this is how the state machine is. In S3 stage, that is after 101, if I get 0, that is 1010. Okay, then I go back to the S2 state. In S2 state, what was there? 10. 10 was already there. It was hoping for another one. So from S3 stage 1010, the pattern of 1011 has broken, but last 2 bit 10 can become the beginning of second pattern which can be detected. So from S3 to the transition happened to S2. So input is 0, output is 0, S2. Again in S2 state, I am waiting for a 1. Okay. So this is how is the state diagram is. Now we will look at the state table. Here is the state table. Here one column is for the present state. Next column you see input is 0. For input 0, I am finding the next state and output. So 2 columns. When the input is 1, next state and output 2 columns. This is I am going to find. So already from the state diagram, S0 is the present state. When the input 0 I am getting, I remaining in the S0 state, output is 0. If I am getting input 1, I am moving to from S0 to S1 state and output is 0. Now I reach the S1 state. In S1 state, if I get the input 0, so 1, 0. So I will move to the S2 state, output is 0. But if I get the input 1, okay, so I will remain in the 1, 1 would be there. So I would remain in the S1 state only and output is 0. Now in S2 state, I reached here. Present state is S2 means 1, 0. If the input is 0, then I go to the S0 state, idle state only and output is 0. But after 1, 0, if I am getting 1, that is the input 1, I am moving from S2 to S3 state and the output is 0. I reach the S3 state, 1, 0, 1. Now 1, 0, 1, if I get 1, if I get 0, so what will happen? 1, 0, 1, 0 it would be the pattern. Last 2 bits can be the beginning 2 bits of the next pattern. So from S3 I move to S2 and output is 0. In the S3 state, if I get 1, so 1, 0, 1, 1 has detected, but the last 1 bit can be the beginning 1 bit of the next pattern. So I move from S3 to S1, but output is 1. Please note this is an overlapping sequence detector. This is the state diagram of a Mealy sequence detector. Now we will see the Verilog code. Now I am starting with the Verilog code of the sequence detector. So tick time scale 1 nanosecond by 1 nanosecond. It is the precision. It tells the time precision. Then the module name is SEQ underscore detector. Inside bracket I am doing the input output port list also making and declaration also I am doing. So input X, comma clock, comma reset, comma output reg Z. So X is the input stream that will be given from the test bench. Clock, the whole system will be synchronized to clock and reset. The signal for which the output would be reset. And here is the output. Output is the Z. Z is the output and it is of reg type. So they are inside the double quotes, then semicolon. Now parameter. So for the states, I am declaring the parameter. 4 states, 4 parameter. S0, I am putting the value as 0, comma, S1 equal to 1, comma, S2 equal to 2, comma, S3 equal to 3, comma. Please note instead of commas, I could have used semicolon. But if I have used semicolon, then there would have been parameter corresponding to S1 also, corresponding to S2 also, corresponding to S3 also. Now I am 2 bits 1 and 0 I am declaring as register type. Okay. So PS, that is the present state, comma NS, that is the next state, semicolon. PS and NS, the present state and next stage they are going to be of 2 bits each. Because how many states are there? 4 states are there. How many bits you need in order to declare 4 states? You need 2 bits. So I am using 2 bits only. So always at the rate of passage of the clock or passage of the reset. So whenever I actually moved into the behavioral block. Okay, always block is a behavioral block, you know, initial block is a behavioral block. So I went inside a behavioral block of always. So always at the rate of passage of the clock, comma, passage of the reset. Means if either of them is true, I am entering the begin end block. In begin end block, I am checking if the reset is there. So the present state would be S0 only, semicolon. And else, the present state would be next state value. Please note, this is the non-blocking assignment. Okay. So this is happening always at passage of the clock or passage of the reset. There is another always block, another behavioral block. Now this always block is active for present state or X. Means whenever the present state is changing always at the rate of PS or X, means whenever the present state make changes or whenever the input stream make changes, I go inside this always block. So there is a begin case present state. Case present state is there. Okay, in present state I have S0. When the case present state is S0, I am getting inside this begin and block. This is the case statement. Case statement, whenever the PS matches with any of the four options S0, S1, S2, S3, then the respective begin and statement will be executed. So if PS is equal to S0, means present state is S0, that means that output is 0, but next state, if the input is 1, then it would be S1, or input is 0, the next state would be S0. So NS is equal to X, question mark, S1 colon S0 semicolon end. Okay, this is a conditional operator. Now if the present state is S1, you can easily make this thing from the state diagram. The state diagram next to the Verilog code and see. For S0, if the input is 1, S1, if input is 0, S0. For the next state, you see. For S0 state, okay, if the input is 0, then you remain in S0 state. If the input is 1, you move to the S1 state. Now, in S1 state, Z is equal to 0, output is 0. Next state, if the input is 1, next state is S1. If the input is 0, next state is S2. So input is 0, next state S1 to S2. If the input is 1, you remain in S1 state only. Now you reach the S2 state. Inside the begin end block, if the present state is S2. Now see, Z is equal to 0. Okay, Z is equal to 0. But next state is equal to is what? Next state is equal to, if the input is 1, next state is equal to S3. If the input is 0, next state is equal to S0. You see in S2 state. If the input is 0, you remain in S0 state. And if the input is 1, you remain in, means it's S3 state. Means for input 0, S2 to S0 transition happen. For input 1, S2 to S3 transition happen. And both the cases output is 0 only. Please see. Now we reach the S3 state. Now we reach the S3 state. We will check for first of all output. In S3 state, if the input is 0, output is 0. If the input is 1, output is 1. So that I have put in the conditional statement here. Z. If the input is 0, if the input is 1, output is 1. If the input is 0, output is 0. And next state also, input is 1, you get the next state is equal to S1. If the input is 0, next state equal to S2. Semicolon, begin, end. And for this particular case statement, I have the end case statement. You see. Always block begin, I have the end statement and end module for the module block. I'm going to write the test bench. So here is the test bench. 1 nanosecond by 1 picosecond is the time precision now. Module test bench, semicolon. Inputs are reg x, reg clock, reg reset. So semicolons. Means reg x semicolon, reg clock semicolon, reg reset semicolon. Then outputs. Outputs is wire Z. Please note all the input which were there in sequence detector, they were initially wire. When you declare in the port list input X clock reset, they are declared by default as wire. But when you write it in the test bench, they become the reg type. while the output, which was declared as reg in the sequence detector port list, now it has become wire here in test bench. So wire Z semicolon. Now I am going to instantiate the DUT. Sequence detector, the instance name is UUT. Now dot X, sequence detector dot X is tied to X here. Port connection is happening, that is comma. Dot clock connected to clock here in test bench, comma. Dot reset connected to reset here in the test bench, comma. Dot Z output is connected to Z in the test bench. Now hold bracket close, semicolon. Here is the initial begin end block. Initially the clock is set to 1 tick B0 semicolon. Reset is equal to 1 tick B1 semicolon. Hash 15 reset is equal to 1 tick B0 semicolon and begin end. Okay. Now you see, these are the initial values provided in the initial begin end block. But this initial begin end block will be run concurrently with this always block and this initial begin end block also. All initial and always blocks, they run concurrently. Now always I am generating the clock. Hash 5. Clock is equal to naught of clock semicolon. That means the clock time period is 10 time units. Now inside the initial begin end block, very easy, I am sending the input stream one after another. After every 10 nanosecond or 10 time units, I am sending the input X. So X is equal to 0 semicolon. After 10 units, X is equal to 0 semicolon. After 10 units, X is equal to 1 semicolons. After 10 unit, X is equal to 0 semicolon. After 10 unit, X is equal to 1 semicolon. After 10 units, X is equal to 1 semicolon. After 10 unit, X is equal to 0 semicolon. After 10 units, X is equal to 1 semicolon. After 10 units, X is equal to 1 semicolon. This is the input stream I have sent. Please note, this is a pseudo code. You have to write it in the VCS simulator or Vivado or ISE in order to simulate the code and see the result. After hash 10 time units, finish, $finish will be called. $finish semicolon end for the initial block and end module for the module statement. So this video, if you like it, share with your friends. Please subscribe the channel and have a very nice day. Bye bye.